This is the second part of the chapter on cylinder and cone. We'll go to the exercise straight away. Exercise 20A, question number 16. A barrel of a fountain pen, cylindrical in shape, is 7 cm long and 5 mm in diameter. A full barrel of ink in the pen will be used up when writing 310 words on an average. How many words would use up a bottle of ink containing 1/5 liter? And in brackets it's given answer correct to the nearest 100 words, and pi value is 22/7. Let's go back to the question. It says a barrel of a fountain pen, cylindrical in shape. Imagine this. This is the barrel of the fountain pen, where you can store the ink. So a barrel of a fountain pen, cylindrical in shape, is 7 cm long, which means the height of this barrel is 7 cm. So I have considered small h is 7 cm. And 5 mm in diameter. The diameter is this length. Okay, this whole length is 5 mm. So diameter is 5 mm. Look at this. The height is in centimeter, whereas the diameter given is in millimeter. So change the millimeter to centimeter. If you have to change millimeter to centimeter, you have to divide by 10. So diameter is 5 millimeter, means 5 by 10 centimeter. That's the diameter, but we actually need only the radius. So radius is half of the diameter, so 5 by 10, half of that into 2 in the denominator. Okay. If you simplify this, you will get 1 by 4 centimeter. So height of this is 7 centimeter and the radius is 1 by 4 centimeter. Okay. Now, this much ink in the barrel can write on an average 310 words. So this much volume of ink which is there can write 310 words. You have to find how many words would use up a bottle of ink containing 1/5 liter. First, let's find the volume of this barrel. So, this barrel is in the shape of a cylinder. Volume of the barrel, which is volume of cylinder, is formula is pi r squared h. Okay. Pi value is 22/7. Radius is 1 by 4. Twice you have tried into 1 by 4 into height is 7. If you simplify this, okay, you can simplify. 7 gets cancelled. 4 goes twice. 22 goes 11 times. So that 11 divided by 2 fours are 8. 11 by 8 centimeter cube is the volume of this barrel. So this much ink, this is the volume of the ink which is there in the barrel. This much ink can write 310 words. So you have to find how many words would use up a bottle of ink containing 1/5 liter. There is another bottle which contains ink, and the ink in that bottle is 1/5 of a liter. So let's find how much actual volume is there. This is given in liters, whereas the barrel's volume that you found is in centimeter cube. This is the barrel's volume. Let's also find the volume of ink that is there in the bottle. So volume of ink in the bottle is 1/5 of a liter is given. So 1 by 5 of 1 liter. This was in centimeter cube, this is in liter. Therefore, change the liter to centimeter cube. 1 liter is 1000 centimeter cube. So 1/5 of 1 liter is 1000 centimeter cube. If you simplify this, that gives you 200 centimeter cubed. This is the volume of ink that is there in the bottle. This is the volume of ink that is there in the barrel of the fountain pen. This much volume can write 310 words, which means this much volume can write how many words is what you are going to find. Okay. So for this, I'll use unitary method. Let's keep this. Okay. Unitary method is what we are going to use. Volume on this side and number of words is what we are going to find. So that's on the right side. In the first case, if this is the volume of the barrel, if volume is 11 by 8 centimeter cube, it can write 310 words. So if this is the volume of ink in the bottle, how many words can it write? So second step, if 200 centimeter cube is the volume, under volume 200 centimeter cube, then it will be writing 310. I have written the same thing. From here to here is division. So divided by 11 divided by 8. 11 by 8, that 8 goes up. Okay. Into the actual volume of ink in the bottle, that is into 200. Okay. So if you simplify this, you will get 45090.90. After simplification of this, you get 45,090.90. Okay. But if you look at the question says answer correct to the nearest 100 words. So this is the actual number of words that you are getting, but you have to round this off to the nearest 100 words. So this is 90.90. If you cancel this, this becomes 91. To the nearest hundreds, 91 is 100 words. So 45,100 words is the actual number of words that the bottle of ink can write. So that's one. Next. This is from the same exercise. Question number 26. Earth taken out on digging a circular tank of diameter 14 meter is spread all around the tank uniformly to a width of 3.5 meter to form an embankment of height 8 meter. Calculate the depth of the circular tank. Okay. I have drawn a figure. Look at the figure. Okay. It says earth taken out on digging a circular tank. This is the circular tank that you are going to dig, which is in the form of a cylinder. Okay. Diameter of this is 14 meter. I have written here diameter, this whole length is 14 meter. If diameter is 14, the radius will be half of this, that will be 7 meter. That's small r's value. Radius from here to here is 7 meter. Now this mud which is taken out is spread all around the top of the tank in the form again of a cylinder of width 3.5 meter. Width of this embankment that is made is 3.5. This distance is 3.5 meter. Okay, which means here also it's 3.5. Okay. Now this cylinder which you are getting, which is the embankment, is a hollow cylinder. It's open from here. This is open. This is open. Right? This same mud which is there is taken out and spread all around. Okay. So it will be something like this. If you look from top, this is what it will look like. This is the circular tank that you are digging. The mud that you have taken out is spread all around here. Okay. So this is what is formed. And it says the height of this embankment is 8. This embankment has a height 8 meter. Okay. Question is calculate the depth of the circular tank. You have to find what is the height of this circular tank that you dug. Okay. Now, you know the radius of this is 7 meter, which means from here to here is also 7 meter. Alright. Now if you look from top, as I said, this is what you will see. The red one is the circular tank that you are digging, whose radius is 7 meter, small r is 7 meter, and the width of this tank, that is this much, is 3.5 meter, which means the radius of the green circle which you are seeing, is from here to here. This much is 7 and this is 3.5. 7 plus 3.5 gives you the 10.5. I have written here. That's capital R is 7 plus 3.5, which is 10.5. Okay. So this same mud is made into this, which means volume of the mud that is taken out from this red color tank is equal to volume of mud that is made as the embankment, which is green in color. Okay. So the relationship here is volume of earth taken out, whatever earth you have taken out from the red tank, is volume of the embankment, the green color that is formed. Okay. Volume of earth taken out is in the form of a cylinder. This red color one is a cylinder. Volume of cylinder is equal to The green color one which you see on top, this one, it is open here, it is also open here, which means this is not a solid cylinder. This becomes a hollow cylinder. Okay. So volume of the mud taken out is equal to volume of the embankment, which is volume of hollow cylinder. The green one is a hollow cylinder. Now to substitute by the formula, volume of cylinder is pi r squared h is equal to volume of hollow cylinder. If you notice, the hollow cylinder has small r and also capital R. Okay. Therefore, the formula is pi, same thing, pi, instead of small r squared, you have capital R squared minus small r squared into height of the embankment. Okay. Now substitute values, you can cancel the pi on both sides, pi gets cancelled. R value, radius of this is 7 into 7, twice you have to write, into height is what you are going to find, is equal to capital R. If you look at this, capital R is 10.5 and small r is 7. Capital R is 10.5 squared minus small r is 7 squared into height of the embankment is 8. This is in the form a squared minus b squared, which can be written as a plus b into a minus b. So this remains the same, 7 into 7 into h is equal to, this I have written as a plus b into a minus b. That's 10.5 plus 7 into 10.5 minus 7 into 8. If you simplify this, that's 7 into 7 into h is equal to, if you add this you will get 17.5, if you subtract this you will get 3.5 into 8. Take these numbers that side, so h is equal to 17.5 I have written as 175 by 10, 3.5 I have written as 35 by 10 into 8 is there, and this 7 and 7 goes down. Okay. And if you simplify this, you will get the height of this cylindrical tank is 10 meter. After simplification, it gives you 10 meter. Therefore, the depth of this tank, depth of the red tank is 10 meter. That's what is asked. We've seen about cylinders. The second figure that you're going to see, the second three-dimensional figure that you're going to see is a right circular cone. A cone. Okay. This is a cone. Now, this lower portion which you see is also in the form of a circle. Take an ice cream cone, okay, the top portion where you fill the cream, okay, where it's open. That is a circular figure. It's a circle. Okay. Now, invert it. This is what you will get. Now, I've named this point as A, this is B, and this is C. This line which I have drawn from here to here is called the vertical height, represented with a small h. This is the vertical height or the perpendicular height, because this line and this line are perpendicular to each other. So this becomes the vertical height, which is represented by a small h, and this is the radius represented by a small r, and this line that you can see for this right angle triangle, this is the hypotenuse. This is called the slant height, which is represented by a small l. Okay. Since this is a right angle triangle, if you use Pythagoras Theorem, hypotenuse squared is equal to perpendicular squared plus base squared. That's according to Pythagoras Theorem. Hypotenuse is this, which is small l, so l squared is equal to perpendicular is this, which is small h squared, plus base is this, base of the triangle is this, which is r squared. Okay. So L is equal to slant height, this one is equal to L squared is this one. So L will be square root of this one. So square root of h squared plus r squared, because you are finding slant height or length is all measured in either centimeter or meter. Therefore, general unit is units. So that's the first formula that you have to know about a cone, how to find the slant height. Okay. The second one that you have to know is the volume that you can occupy in this. Okay. Volume of anything that can be filled inside this cone. Okay. So the second formula is volume. Volume of a cone is given as, previously volume of cylinder was only pi r squared h, but volume of cone is 1/3 pi r squared h. 1 by 3 is a constant, numbers, pi also is a constant, 22 by 7. R is the radius of the base of the cone and h is the vertical height of the cone. Okay. So 1 by 3 pi r squared h, you are finding volume, therefore unit is unit cube. It can be centimeter cube or meter cube. Then the third thing that you can find for a cone is the curved surface area. Now let's go back to the figure. If you look at this cone, there's one surface here which is flat and this is curved. Okay, this portion is curved. If you take the ice cream cone, if you're holding the ice cream cone, you are actually holding the curved surface area, right? So this is the curved surface area. So to find curved surface area, all that you have to know for curved surface area, short form CSA, is given as pi r L. Pi is 22 by 7, r is the base of the cone and L stands for slant height. So to find curved surface area, you have to know radius and slant height, not the perpendicular height or the vertical height. Okay. Because you are finding area, unit is unit square. Right? Then the last formula is total surface area, in short TSA. Total surface area, let's go back to the figure. How many surfaces does it have? One is this curved one surface, and the other one is flat, which is in the shape of a circle. Therefore, total surface area is the curved surface area CSA plus the base is in the shape of a circle. So area of the base, which is a circle. Curved surface area is pi r L plus area of the base, which is in the shape of a circle, is pi r squared. Common here is pi and 1 r that I removed. So see what is left. L plus one more r is there. Since you are finding area, again unit is unit squared. Okay. So these are few formulae that you have to know about a cone. And your homework for today is exercise 20A, question numbers 36 and